Now we're going to talk about some equations and proportions and how to solve those. Here's a strategy for solving equations that I've used for many years, and it's very helpful. The first thing you should do is go ahead and eliminate any fractions by cross-canceling with the LCD. You'll recognize that abbreviation as the least common denominator. I'll demonstrate this later. The second thing is you go ahead and eliminate parentheses using the distributive property. Now the distributive property, as you recall, is when you multiply the number in front of a parentheses by every term inside of the parentheses. The third thing to do, just to make it more efficient, would be combine like terms that are on the same side of an equation. Then you can move terms left or right by adding or subtracting. That will isolate the variable, which is the letter. And only last should you divide each side by the coefficient of x. That is the number in front of x. Now, when you do this procedure of solving, three things could happen to you. Thing one, you could get a single solution or an answer. If that happens, then you have a conditional equation. Thing two is you could get a solution in which every number in the world works, all real numbers. That's called an identity. And thing three is you could get a no solution. No answer in the world works, and that is normally demonstrated with this symbol of the zero and the line through it. That's called an inconsistent equation. Now here are some examples that just involve one step. If you notice in the first equation, if I were to move over the negative 17, it changes signs. When you move terms side to side with addition or subtraction, you use the opposite sign. That would leave the x on the left, bring down the equals, and 6 plus 17 would be 23. That's what we call the solution or the answer. Now in the second example, you'll notice it has a fraction. And I said that you could eliminate fractions if you cross-cancel with the LCD. The LCD common denominator here is 6. So I will put a parentheses and a 6 beside both terms on both sides of the equation. Now since this is a different process from moving a term, you do not change the sign. Use the positive 6. Now if you recall, 6 is a whole number, 6 over 1. Now you can see the 6 at the top and the 6 at the bottom, which cross cancel. That will leave 1 times x, which is x, and 3 times 6, which is 18. That's the solution. And in this third example, you have to get rid of the 4. You always will eliminate the coefficient by dividing by that number in front of x. When I divide, you'll notice I put a fraction bar that symbolizes division, and it leaves us x equals 5 as the solution. Now here are examples of multi-step equations. If given the first one, I would move the 14 over first to make it be positive 14. That will leave 5x equals a negative 75. Then I would divide by 5. Always divide as your last step. And when you divide that, remember your sign rules. So x is equal to negative 15. In this other equation, I would need to eliminate the parentheses. So I multiply using the distributive property to get 10x minus 35. Do not multiply that minus 2, just bring that down. Then multiply on the other side of the equals to get 5x minus 20, and then bring down the 8. Next, you would need to combine the like terms that are on the same side. So I have negative 35 minus 2, which is negative 37. And I have negative 20 plus 8, which is negative 12. Now and only now would it be most efficient to start moving terms. If I move the negative 37 across the equals, it becomes a positive, leaving 10x equals 5x, and I combine those two numbers to get 25. Then I will move that 5x across the equal, and it becomes a negative 5x. 10 minus 5 would give me 5x equals 25. and then I divide both sides by 5. The solution here is x equals 5. You can always check an answer by plugging it back into the original problem. Now here are some other examples of what could happen. In this first problem on the page, if I use a distributive property, notice that I get 4x plus 24 over on the right-hand side. Now when I go to move terms, for instance, that negative 5 comes over to be positive. I have 4x equals 4x plus 29. And I move that 4x and it becomes a minus. So 4 minus 4 is 0x, which is just 0, equals 29. This is false. Notice the x terms canceled out and it left you with a false statement. If you're left with something false that cannot be true, then this is no solution. It is inconsistent. On this second example, if I use a distributive property to eliminate those parentheses, I bring down the other terms, and then I combine my like terms that are on the same side to make it a little easier. 11 minus 3 would give me 8x. Positive 5 and positive 1 would be positive 6. Now if you notice, 8x plus 6 is on both sides of the equation. Right there, you could stop and say that the answer would be all real numbers. This is called an identity, as I said before. That's because the terms are identical. But what if we kept going? Well, if I move the positive 6 over, it becomes minus 6. And that's just cancels in 0. If I move the 8x back over, it becomes a negative or a minus 8, leaving 0 equals 0. So again, the x terms cancel out, but you fundamentally have a true statement. 0 is equal to 0. That means the answer is all real numbers also. Now, how do you eliminate fractions with the LCD again? If you have multiple fractions, look for the least common denominator. I always try to check the largest number, which is 28 here, and 4 and 7 will both divide into 28. If that did not work, then I would multiply those denominators together. But here we're going to use 28. So I'm going to put parentheses 28 beside each one of these terms and cross cancel. Remember, when you cross cancel, that's just like dividing. So 28 divided by 4 is 7, so I have 7 times x. 28 divided by 7 is 4 times x. 28 divided by 28 is 1, and that's 11 times 1. I get 7x plus 4x equals 11. Combine these like terms on the left to get 11x. Divide by that coefficient 11, and x is equal to 1. That's my solution. Now, another very useful equation, especially in the career and technical fields, would be the proportion. A proportion is an equation that has two equal ratios, like 2/3 equals 4/6. We will always cross multiply to solve these. In this example, I simply multiply across the numerator and denominator. 4 times 7, and then 2 times x. Well, 4 times 7 is 28, and that's equal to 2x. Divide by the coefficient 2, and x will be 14. Final answer. Now, another useful way to use proportions is in an application. Here we're told that a person's blood, the volume of blood, is proportional to a person's weight. So we can actually demonstrate blood to weight in a fraction form, or weight to blood in a fraction form. It doesn't matter which one you put in the numerator or denominator as long as you're consistent. So we're going to set two fractions equal to each other to form a proportion. Here I have a person who weighs 140 pounds, so I'll start with weight, and that person has approximately 4 quarts of blood. It says estimate the number of quarts of blood in a person who weighs 160. Well, I'm forced, since I started setting it up this way, I have to put 160 pounds, and that's equal to x, my unknown. Now remember, I could have set this up a different way. If I wanted to start with the unknown, I could have had x over 160, and then I would have needed 4 over 140. You will get the same answer either way you set it up. Now we're going to cross multiply to get 140x is equal to 640. Then I would divide by the 140 coefficient, and x is equal to approximately 4.6 if you round off to the nearest tenth. Here is another proportion problem, and here we have an alligator's tail length is proportional to the body length. It has a symmetry. We have an alligator with a body length of 7.3 and a tail length of 8.2. So that's the tail and this is the body. What is the tail length of the alligator whose body is 8.1? Let's set this one up starting with the unknown. We want the tail length. So we're going to set it up as tail length compared to body length. So the tail length we would not know on this new gator. The body length is 8.1 feet. Now since I put tail in the numerator, I have to put the other example tail measurement in the numerator, and it said the tail length was 8.2, and that had a body length of 7.3. Okay, so let's go ahead and let's cross multiply. I end up with 7.3x, and then 8.2 times 8.1 will give me 66.42, and I divide by 7.3. And that is approximately a 9-foot gator, 9.1 feet.